All right, today I'm just going to talk a little bit about sums of a sequence, which, when you look at our definitions, is a series. So remember I said the difference between a sequence was just a list of numbers, whereas a series is when we put a plus sign and add them all up. So a sum of the sequence. Okay, so there we go. So term 1 plus term 2 plus term 3 plus all the way up to whichever the last term is that we're going to add up. We say, well, that's the sum of all the n terms. We have another notation here, sigma notation. I think the last time we saw that notation again might have been in stats. You remember those frequency distribution tables that you did? Down the bottom we went sigma f, sigma fx. No, don't panic, we're not doing those. So, but that's where we saw the symbol. I mean, that capital sigma means sum of. So add all these together. So a shorthand way of writing out this whole sum, what they do is they say, well, here's the general term for the pattern. And we want to add up from when k equals 1 up to k equals n, or however far we go. So it says writing out the whole sequence. So this one here, n equals 1 to 5, and there's the pattern, 2n plus 3. Now later on we'll see formulas for this, but at this stage, well, I'll substitute 1 in, and I'll get 2 plus 3. I'll substitute 2 in, and I'll get 4 plus 3, and so on and so on and so on. Until I get to the last one, I'll get 10 plus 3, and all that adds up to 45. Now, here's the interesting thing. If they tell me that the sum of the first 10 terms is 29, and the sum of the first 11 terms is 37, well, then I can go and find the 11th term. Because the 11th term must be the sum to 11 terms minus the sum to 10 terms. So if I take away the sum to 10 terms, I'm left with what I added on, the 11th term. So they've told me an answer for those, 37 and 29. I get the answer, well, I know the 11th term of this pattern is 8. All right, they've given us a formula, but this time it's not the general formula of a number pattern. It's a formula to find the sum, and they want us to find the general term. Well, I can use the same idea that I just did. Because I could say, well, term n, if I got sum of n terms and took away the sum of n minus 1 terms, then I must be left with the nth term. So I use exactly the same idea. So substitute in, by the way, they're not absolute value symbols. They're actually square brackets, and I don't know what happened to the top and tail of them. So there are actually brackets there. What's it look like on your sheet? Does it look like absolute value there as well? Right. Yeah. Okay, so sum to n, 5n squared minus 2, minus, now I'll sub in n minus 1 everywhere I saw an n. So 5n minus 1 squared minus 2. Let's see what we get. Expand the whole thing out, collect like terms, the n squareds disappear, and there's my general term for the pattern, 10n minus 5. Ooh. One of the things to be careful with, I didn't mention it there, watch out in sigma, don't assume that they're always going to start at term 1. Sometimes they might say, sigma n equals 3 to 7. So in that case, the first one you'd sub in would be 3, and so on, up to 7.